Welcome to the Health AI Brief, breaking down the AI shaping our world one concept at a time. In our last episode, we talked about the exploration-exploitation dilemma and the challenge of sparse rewards, where an AI struggles to learn because positive feedback is rare. You can't have an AI randomly trying ventilation strategies hoping to stumble upon a good outcome. So how do we guide an AI to learn effectively in these complex situations? The answer is an approach called curriculum learning, and it's an idea that we know intimately in medicine. The analogy is medical school itself. We build knowledge layer by layer, first basic sciences, then simple clinical skills, then shadowing on the wards. We provide a curriculum that starts simple and gradually increases in complexity. Curriculum learning does exactly the same for an AI. Instead of throwing a massive, messy dataset at it, it's trained in stages. The benefit of this structured curriculum is that it shapes the reward landscape. By starting with an easy task, the AI gets frequent positive feedback, which helps it learn a solid foundational understanding of the problem. It can then build on that foundation to tackle harder versions, making the whole process much faster and more reliable. For an AI learning to identify fractures on an X-ray, a great application in action, the curriculum might begin with textbooks, undisplaced fractures. Once it masters those, it moves on to comminuted fractures, then fractures in osteoporotic bone, and finally subtle hairline fractures on technically poor films. There's two main ways of designing a curriculum. Sometimes it's done manually, with human experts defining the stages, just like a training program director designs a rotation for students. But increasingly we're seeing automated approaches where the AI itself helps to choose the next lesson. It identifies tasks that are not too easy and not too hard, but are productively difficult, the zone where it learns most efficiently. So the clinical takeaway here is about robustness and generalizability. When you see a study proposing an AI for complex clinical tasks like managing sepsis or optimizing a radiotherapy plan, look for any mention of how it was trained. If the paper mentions curriculum learning, it's a strong sign that it's a thoughtfully designed system. It suggests that the AI's knowledge was built in a logical, structured way, making it more likely to be robust when faced with a complex real-world case that it hasn't seen before. So now that we can understand how we can structure an AI's education, our next step is to look under the bonnet of its two main learning philosophies. We'll start next time with the AI that acts like a meticulous judge. So that's curriculum learning in a nutshell.